Hello friends, this is Gangadhar from the YouTube channel Maths Gangadhar. In this video, I am going to discuss about the proof of the triangle inequality from the modulus function. In the last video, we discussed the definition and different examples related to the modulus function. Basic inequalities, basic equalities of the modulus function we discussed in the last video. Okay. Now, in this video, we are discussing about the triangle inequality, and the modulus function is very helpful in attempting almost of all the competitive examinations. Okay. If you are confident about that modulus function, then it gives us more ease to solve those type of problems. To get that confidence, let us follow the proof for the triangle inequality, and in the next videos, coming videos, I am going to deal with the different problems which are very simple to solve using this triangle inequality. Coming to here, we are going to solve the triangle inequality of the modulus function, and that is mentioned as modulus of mod x minus mod y is less than or equals to mod x plus y is less than or equals to mod x plus mod y. Okay, initially, why we are calling it as a triangle inequality? Since it follows the basic triangle inequality of the plane geometry. What is the basic triangle inequality of the plane geometry? In a triangle, difference of two sides is always less than the third side, and which is less than the sum of the two sides. So if you create mod x as well as mod y and mod x plus y as three sides of the triangle, difference of these two is nothing but modulus of mod x minus y. Difference of two sides is less than the third side is less than the sum of those two sides. Since it is resembling the basic triangle inequality, we are calling this as the triangle inequality of the modulus function. Okay, so the triangle inequality is what? Modulus of mod x minus mod y is less than or equals to mod x plus y is less than or equals to mod x plus mod y. So before going to start, I just revised we call the definition of modulus function, and we are very familiar with the definition of modulus function. What it is? See, modulus function works like summation. If you give a positive input for the modulus function, it multiplies the positive input with the plus sign and results out. The result is positive. Whereas if you give a negative number to the modulus function, it multiplies the negative input with the negative sign and results out the positive value. Whereas if you give the 0 for the modulus mission, it results as 0 itself. So, positive number is multiplied with positive sign with modulus function. Negative number is multiplied with negative sign with modulus function, and 0 is always remain like 0 itself. So what it means, the modulus function always gives us 0 or the positive value. So we call that modulus of x, or the modulus value is always non-negative. Okay, so this definition in detail is discussed in the last video. Okay, if you have any doubt or the confusion, just go through the video also. Right? Now, see what we are going to solve. See, finally what I told you is modulus of x is always positive. Either if x is negative or if x is positive, the result is positive. So modulus of x is always positive. So since modulus of x is always positive, we mentioned that this modulus where if x is positive, then what happens? For suppose if x is positive, x and modulus of x both are same. Whereas if x is negative and mod x is positive. So this value is less than that x. So x less than or equals to mod x or x. If x is positive or if x is negative. In both the cases, we have that x is less than or equals to mod x. Okay, right. In the same way, we have another one that y is less than or equals to mod y. Since x is less than or equals to mod x, y is less than or equals to mod y. If you add these two, you get that x plus y is less than or equals to mod x plus mod y. And in the other side, again, if you took minus x and mod x, I am going to compare minus x and mod x. See, now in this case, if x is positive, this minus x is negative. If x is positive, the left side is negative, whereas the right side is always positive. Okay, so negative value is less than mod x. Whereas if x is negative, minus of minus is positive, and this is also positive, both are get same. See, in both the cases, if you observe either x as negative or x as positive, in both the cases, minus x is also less than or equals to mod x. Since minus x is less than or equals to mod x, in the same way, for the number y, we have that minus y is less than or equals to mod y. Again, if you add these two, we have that minus of x plus y is less than or equals to mod x plus mod y. Now, if you observe, this x plus y is less than or equals to mod x plus mod y. This minus of x plus y is less than or equals to mod x plus mod y. If you multiply both the sides with the negative sign, the inequality get changed, and you have that x plus y is greater than or equals to minus of mod x plus mod y. Now, if you observe these two, what are those two? X plus y less than or equals to mod x plus mod y, whereas x plus y greater than or equals to minus of mod x plus mod y. By combining these two, you will get the second part of the triangle inequality. How you will get the second part? By combining these two. Just look here. If you treat for our convenience as mod x plus mod y as some a, and what we have from here? From here you have that x plus y, okay, is less than or equals to some a. If you treat this as a, and from this what we have? If you treat this as a, we have that minus a is less than or equals to x plus y. X plus y is less than or equals to a, minus a is less than or equals to x plus y, and by combining these two, what we have? Minus a is less than or equals to x plus y is less than or equals to a. Since minus a is less than or equals to x plus y is less than or equals to a, this is very clear that modulus of x plus y is less than or equals to a. Since modulus of x plus y is less than or equals to a, this is the second part of the triangle inequality. Modulus of x plus y, okay, is less than or equals to a. What is a? Mod x plus mod y. Okay, so there is the second part of the triangle inequality. If you look here, what I did, see, we are very familiar with the definition of modulus function. From this definition, it is clear that modulus of x is always positive. Okay, so for the positive quantities, mod x and x both are same, whereas for the negative quantity, mod x is greater than that negative value. So if I took x and mod x, sometimes x is positive and sometimes x is negative. If x is negative, this value is less than or equals to mod x. If x is positive, both are same. By combining these two, I have that x is less than or equals to mod x. So since x is less than or equals to mod x, similarly y is less than or equals to mod y, adding these two, x plus y is less than or equals to mod x plus mod y. The similar work is happened with minus x and minus y also. Minus x is less than or equals to mod x, minus y is less than or equals to mod y, add these two to have that minus of x plus y is less than or equals to mod x plus mod y. And then if you multiply with a negative sign, x plus y is greater than or equals to minus of mod x plus mod y. Combining these two, by treating mod x plus mod y as a for our convenience, we have that x plus y is less than a and minus a is less than x plus y. So we have that mod x plus y is less than or equals to a. What is a? A is mod x plus mod y. We treat it as mod a. So mod x plus y less than or equals to a is nothing but mod x plus y is less than or equals to mod x plus mod y. So that ends the second part of the triangle inequality on the modulus function. Okay, and one more thing, if you look here, okay, if x is positive, then the equality holds. If y is positive, it also inequality holds. Okay, so whenever the inequality holds here, if x is positive and y is positive, so if both x and y are positive, the equality holds here. And the same case coming to here, if x is negative, then the equality holds. Here also if y is negative, then the equality holds. Here also we will get the equality sign if both x and y are negative. Okay, so finally what we conclude is, if both x and y are positive or either both x and y are negative, we have the equality sign in the second part of the modulus function. That magical logic is very useful in solving so many problems in a simple manner. Okay, so finally this is the second part of the modulus function, and I am going to deal with the first part of the modulus function now. Okay, so let us look here, right? So finally the second part of the modulus function is mod x plus y is less than or equals to mod x plus mod y. And what I mentioned now, I mentioned one more rule here, mod x plus y is equals to mod x plus mod y. Whenever it happens, mod x plus y is equals to mod x plus y. It is true if both x and y are positive as well as both x and y are negative. Okay, so keep in mind, okay, which is very useful in solving so many problems, right? So now coming to prove the first part of the triangle inequality, further we have to prove that modulus of mod x minus mod y is less than or equals to mod x plus y. This part we are going to prove. Okay, to prove this part, what I am going to do? So for that I am considering, we have to consider initially mod x. If you consider mod x, I will rewrite this mod x as modulus of x minus y plus 2. Add and subtract y. See, this is modulus of x minus y plus 1. Already we have the second part of the modulus function. From that second part of the triangle inequality, this mod x minus y plus y is clearly less than or equals to mod x minus y plus 1. So what I have, mod x is less than or equals to mod x minus y plus 1. If you send mod y this side, you have that mod x minus mod y is less than or equals to, okay, modulus of x minus y. Actually we are going to prove that what? Modulus of x minus y. This is less than or equals to modulus of x minus y I have here. So actually I am going to prove that modulus of x plus y. So for that what we need to consider, we have to just consider x plus y and then here with the minus y. Okay, see, x plus y with minus y also will give the same logic, and from there with the second part we have that which is less than or equals to mod x plus y, less than or equals to modulus of minus y, treating it as plus of minus y. Okay, now this modulus of minus y is again equals to mod y itself. Modulus of minus y and mod y both are same. So now you send here mod x minus mod y is less than or equals to modulus of x plus y. This is the second part. So mod x is relating as x plus y minus y. So this is from the second part is less than or equals to mod x plus y plus mod minus y. Mod minus y and mod y both are same. So if you replace this mod minus y with mod y by sending it this side, mod x minus mod y is less than or equals to mod x plus y. Okay. Now in the same way, if you consider mod y, again you just write this mod y as mod y plus x minus x. Now again I am writing it as this is less than or equals to mod y plus x plus modulus of minus x. This modulus of minus x is again nothing but mod x. Okay, this value is again equals to mod x. If you send it this side, you have that mod y minus mod x is less than or equals to mod x plus y. Okay, so by starting with mod x, I have that mod x minus mod y is less than or equals to mod x plus y. And by starting with mod y, I have that mod y minus mod x is less than or equals to mod x plus y. So if you look these two, okay, difference of mod x and mod y is always less than or equals to mod x plus y. Okay, sometimes mod x is greater, sometimes mod y is greater, and so to identify the difference, we are considering the modulus for these two. So finally, modulus of mod x minus mod y is less than or equals to mod x plus mod y. Okay, in both the cases, this difference is less than. So combining these two, we have this second part of the triangle inequality. Okay, so previously we discussed the second part of the triangle inequality. With the help of this second part, we proved now the first part of the triangle inequality. By combining those two parts, what I have the modulus of mod x minus mod y is less than or equals to mod x plus y is less than or equals to mod x plus mod y. Okay, so let us look here. What we did to prove this part, we considered mod x. We write this mod x as mod x plus y minus y. With the help of second part, this is mod x plus y plus mod minus y. Mod minus y and mod y both are same. If you send this mod y to this side, mod x minus mod y is less than or equals to mod x plus y. Similarly, we have this one. Combining these two, we prove the first part. Okay, so finally, the triangle inequality is modulus of mod x minus mod y is less than or equals to mod x plus y is less than or equals to mod x plus mod y. Okay, and after proving this triangle inequality, after accepting this, we will generate one more thing from this one, this triangle inequality. What it means, if you replace y by minus y, if you replace y by minus y, then what happens? Modulus of mod x minus mod minus y is less than or equals to modulus of x minus y is less than or equals to mod x plus modulus of minus y. Replacing y with minus y everywhere in the triangle inequality. See, after norm simplification, we have that mod x, and already I mentioned that mod minus y is again equals to mod y. So mod x minus mod y is less than or equals to mod x minus y is less than or equals to mod x plus mod y. That means the triangle inequality is not only true for x plus y in the middle one, but also for x minus y. So by combining these two, we need to keep in mind that the triangle inequality is modulus of mod x minus mod y is less than or equals to modulus of x plus or minus y is less than or equals to mod x plus mod y. Okay, and this triangle inequality is very useful in solve different types of problem in very simple way, and this is a must and should knowing concept for almost all the competitive examinations. Okay, I think this will help you. This will raise your confidence in solving certain problems. And in the next video, I am going to discuss different problems related to this. Okay. Anyway, thank you. Thank you for watching. Thank you.